At Ar-Rahman International School, discover your career path. Engineering and science shape the future.
Last week, our school successfully conducted a Career Mela and Science Expo to introduce students to future career opportunities in engineering, technology, science, and research. Students actively participated by presenting models and projects related to rockets, space science, computers, and engineering concepts. They learned about how engineers design machines, how scientists conduct experiments, and how technology helps solve real-world problems. Through this expo, students understood the importance of innovation, creativity, and scientific thinking. It encouraged them to explore different career paths and develop interest in science and technology from an early age. We sincerely thank our parents for their support and cooperation in making this event a great success. Together, we aim to guide our children towards a bright and meaningful future.
Good morning everyone, my name is Anya Fatima. I am a mining engineering school. I study physics, chemistry, mathematics, biology and basic geology because these are from the foundation of mining engineering. After school, I complete B.Tech in mining engineering at Indian Institute of Technology.
Good morning everyone, my name is Hania. I am a mechatronics engineer learning pathway. My interest began with science and mathematics in school. In higher secondary, choosing physics, chemistry and mathematics. After school, I studied mechatronics engineer at Indian Institute of Technology, Mumbai.
Engineering department is a career about designing, building, operating and improving structures. The careers listed here include traditional careers such as civil, mechanical, electronics, specialized areas like automobile, aerospace and aeronautical, interdisciplinary like naval architecture, biomedical and pharmaceutical.
My name is Harshit.
My name is Pratap.
I am the commander of the space mission.
I am also commander of the space mission.
As a commander, my role is not to build the mission alone, but to coordinate engineers, ensure safety, and make sure every system are working together. I studied physics, chemistry, and mathematics in school because space missions are built on scientific fundamentals. Later, I studied aerospace engineering at IIT Kanpur, where I learned how the rockets are designed, tested, and flown safely. Before we begin, let me break a common myth. A rocket is not built by one engineer or one branch. It is built by many engineers working with one purpose. A rocket is not one subject. It is a giant group project. If even one team fails, the rocket will not move an inch.
Stage 1, mission purpose. Why am I building this rocket? Before designing the rocket, engineers first decide themselves in the control room. Communication, weather, monitoring, navigation, all scientific research. Engineers involved. Space scientists, system engineers. Stage 2, aerodynamic design. This stage decides the shape of the rocket. The nose of the rocket is cone-shaped because it reduces air resistance and prevents turbulence. Engineers involved. Aerospace engineers, mechanical engineers and design engineers. Stage 3, material selection. What materials should be the rocket made of? Rocket face extreme heat, temperature and pressure, so special materials are needed. Engineers involved, mechanical and metallurgical engineers and nanotechnology engineers.
Stage 4, propulsion system. The propulsion system provides a massive thrust needed to overcome the Earth's gravity. Engineers involved, mechanical engineers, chemical engineers, and petroleum engineers. Final conclusion. As a commander, I do not fly this mission alone. I coordinate engineers, trust system, and depend on teamwork. A rocket is not built by one engineer. It is built by many engineers working with one purpose. Rocket மேல போகுது ஆனால் successfully எனக்கு ரெட்டியூல இருந்து வருது. Thank you.
As you can see, the Smart Harbor design optimizes shipping routes using AI.